Hey kiddos! Today we're going to continue talking about triangles, and there are 4 different things we're going to specifically talk about in triangles, and that is medians in triangles, altitudes in triangles, perpendicular bisectors in triangles, and angle bisectors in triangles. So let us begin with the median of a triangle. We have segment AZ, segment BY, and segment CX are known as medians. The points X, Y, and Z are considered midpoints. A median is a segment whose endpoints are a vertex of a triangle and the midpoint of the side opposite. Okay, so notice here all 3 medians, when they intersect at a common point that is called the centroid. So, first example, find the value of x and the measurement for segments CX and BX. They are telling us that AX is a median. Okay, so there should be something important that we understand that happens here, and that is that this median is this segment here that's cutting this segment into two congruent pieces, okay? Because X is the midpoint, okay? So CX is going to be congruent to XB, okay? Or BX. So to solve here, all we have to do is set them equal to each other. So CX is 4x plus 6. We're going to set it equal to BX, which is 7x minus 9. Now, let us solve for x. I'm going to subtract 4x to both sides. 6 equals 7x, take away 4x, leaves me with 3x. Minus 9. I have to get rid of the minus 9 by adding 9 to both sides. 15 equals 3x. That canceled out. Last step is to divide both sides by 3. 15 divided by 3 is 5. So x equals 5. And they were asking for the value of x and the measurement of those two segments, CX and BX, which if you know one, then you automatically know the other. So let's just pick one of those equations to substitute x into, and I'm going to pick the 4x plus 6, which is actually 4 times 5 plus 6. 4 times 5 is 20, plus 6 gives us a total of 26. So CX is 26, and BX is also 26. All right, next example. Find the value of x and the measurement for segment CY. I'm going to let you guys attempt this problem on your own. It is very, very, very similar to the previous problem, okay? We're looking here, and they're telling us that BY is our median, okay? So because of that, then therefore AY is congruent to CY, okay? Knowing that, you should be able to solve for X, and then you should be able to figure out what the segment CY is. So on your own, yo. All right, now moving on to the next. Let's talk about altitudes of triangles. Okay, a altitude of a triangle is a segment from a vertex and is perpendicular to the side opposite. Okay, notice all 3 altitudes that can be created inside of a triangle intersect at a common point called the orthocenter. So what we're saying here is that you got AZ perpendicular to BC, hence the 90 degrees there. Then you got BY perpendicular to AC. Then you got CX perpendicular to AB. So notice that's why we have those 90 degrees angles marked there, okay? AZ, BY, and CX are all called altitudes, okay? Another thing here is altitude represents the height of a triangle. Okay, so you guys remember area of a triangle, base times height divided by 2. To have the height of a triangle is basically being able to find the altitude of it. All right, example. Find the value of x and the measurement of angle ATB. So I know I have to figure out what x is. Where is angle ATB? ATB is this angle here. All right, now what they're giving us is that AT is an altitude. So if it's an altitude, then yes, we can justify why this right angle is here. Okay, now just curious, if that's right angle and this is a straight angle, straight line, right? And hopefully we recall that the measurement of straight angles um, is 180 degrees, meaning that those two angles are supplementary. So if this is 90 degrees, then therefore this would have to also be 90 degrees. So we have discovered that the measurement of angle ATB is equal to 90 degrees. Now all we got to do is figure out what the value of x is. So we're just going to take 4x minus 6 and make it equal to 90. All right, solving for x. I'm going to add 6 to both sides. We get 4x, that canceled out, equals 96. Last step is to divide both sides by 4. And when you do 96 divided by 4, you get 24. So our two answers are that the measurement of angle ATB is 90 degrees and the value of x is 24. Second problem. Find the value of x and the measurement of angle BZA. If AZ is an altitude, AZ right here, AZ is an altitude, which means we can justify why this 90 degrees right here. Then the question is, find the angle measurement of BZA, which is this angle here, and figure out what the value of x is. This is exactly like the previous problem we just did, so yo, try it on your own, and we'll check to see if you got it tomorrow or next time in class. All right, next concept. Something actually you guys have already seen before. We have talked about angle bisectors before, okay? We know the key thing here is what the word bisect means. We know that bisecting means that it's cutting something into two congruent pieces, all right? So, in a triangle, you can have angle bisectors. Notice here, ray AZ, ray BY, and ray CX are all angle bisectors, okay? An angle bisector is a ray that divides an angle into two congruent angles. So as you can tell here, you can see these markings here. So angle B here is the split into two equal pieces. Angle A up here is split into two congruent pieces. And then angle C is split also into two congruent pieces. Okay. All three angle bisectors intersect at a common point, and this point is known as the incenter. So, example, find the value of x and the measurement of angle BAJ and angle CAJ. Okay, AJ, ray AJ, kind of tongue twister, ray AJ is an angle bisector. Okay, so they're telling us this is an angle bisector, so I can justify making these markings look alike, essentially, because I know that they are going to be congruent. So, if measurement angle BAJ is 9x minus 10, and the angle CAJ is 7x plus 6, how are we going to figure out what their measurements are and what is the value of x? Well, hopefully you're saying it. All we have to do is make them equal to each other. because an angle bisector creates two angles that are in fact congruent. So we are going to solve for x first, and then we can plug that answer in to figure out what the actual angle is. So subtracting 7x to both sides, I get 2x minus 10 equals, that canceled out, 6. I'm going to add 10 to both sides now. You get 2x equals 6 plus 10 is 16. Last step is to divide both sides by 2. And we get a grand total of x equals to 8. So that's the first part. We know that x equals 8. Now to figure out what those angles are, we just need to pick one to plug it into. So I'm going to use the 7x plus 6, because we know both of them are supposed to be the exact same answer. So 7 times 8 plus 6. 7 times 8, 56, plus another 6, gives us a grand total of 62 degrees. So our angles BAJ and angle CAJ are both going to be equal to 62 degrees. Now, if I had asked for what is the measurement of angle BAC, hopefully you would have recognized that we would just have to add these two answers together to get that whole thing. Moving on. All right. Number 3. Find the value of x and the measurement of angle ACX. I'm going to help you guys out here. Mark it too in red. And angle BCX. All right. They're telling us here that ray CX is the angle bisector. They're also telling us that the measurement of ACX is 3x plus 23. And the measurement of BCX is 7x plus 19. This is exactly like the previous problem. So, of course, I'm going to let you guys do this on your own. Oyo. Whew. I'm sure you guys did just perfectly fine with that last problem. So moving on to the last concept, and that is a perpendicular bisector. Now, two words being put together, and we know what both of them already mean. Perpendicular, we know, means that it creates 90-degree angles. Bisector, we know, splits something into two congruent pieces. So, let us look and see what happens. W, Z, R, Y, X, U are perpendicular bisectors. X, Y, Z are midpoints. So, a perpendicular bisector is a line, segment, or ray that passes through the midpoint of a side, okay, and is perpendicular to that side. All three perpendicular bisectors intersect at a common point called the circumcenter. And yes, you must know all of these names for all of the different ones. So that means there are 4 different ones which have 4 different names for the point that they intersect at. So let's go into an example. So find the value of the line segment AB. So what we have here is line CA is a perpendicular bisector of triangle DAB. I can say that because I noticed 2 things. I noticed that C has to be the midpoint because it is split into 2 congruent pieces. So there's one part of the perpendicular bisector. And the second part, obviously, it's got the 90-degree right there, which tells me it's perpendicular. So CA is a perpendicular bisector here. Now I'm going to use prior knowledge to help me justify why DA is congruent to BA. You hopefully recall the reflexive property, which means we can make that marking right there, which would then establish that this is side, angle, side. So if it is a true triangle congruency that we can justify, which we can, then that would mean that these two sides would have to also be congruent. So 5x plus 12 equals 8x. We're going to subtract 5x to both sides. That cancels out. 12 equals 3x. Divide both sides by trace. And we get that x is equal to 4. That's not what the question asked for, so don't stop there. So what is the measurement of AB? So line segment AB is equal to 8x, or in other words, 8 times 4. And 8 times 4 leads us to conclude that the line segment AB is 32 units. Number 4, find EF. Again, we can establish here that HF is a not just perpendicular, but it's a perpendicular bisector, okay? Because we can see that they're telling us that EH is 8 and that GH is also 8. So telling us that this point, H, is the midpoint. We clearly see that it has 90 degrees, which means that FH is perpendicular to EG. So this is actually just like the previous problem. I can justify reflexive property, which means I know that these two triangles are congruent, which means I can make 2x plus 5 equal 2x plus 10 to justify finding what the value of EF is. So subtract x to both sides. X plus 5 equals 10. Subtract 5 to both sides. X equals 5. Not our answer. Gotta plug it in. Looking for EF, which is 2 times x plus 5. X is 5, so 2 times 5 is 10 plus 5 gives us that segment EF is congruent to 15. Well done. Bravo. Ciao.